muted and our video is on.
Hi, everyone. We'll be starting shortly.
How many participants? Yeah.
Sorry, I have to jump on here. We'll just make sure that you're standing in front of the laptop. That's what it's going to take. Oh, yeah, it's still showing them. This is just the minimized screen. It's showing Laura's name, but you're on the main screen. It's showing mistake. You should be good to go.
Okay, I'll introduce the session. Okay, thank you all for coming. This is the New Technologies Key to Agriculture Future Sustainability breakout session. So if that's not the one you want, then go to another room. We have 3 speakers and we're going to let them speak back to back, and then we'll have questions at the end. We have a lot of people on Zoom, and so we want to make sure our speakers talk into the computer, and if someone asks a question, we'll ask that you repeat it, and I'll remind you as we go on. But without further ado, we'll have our first speaker, Colleen Hanley, who is the Food Systems Research Specialist at the Swette Center for Sustainable Food Systems here at ASU. Thank you, Colleen.
Thank you, Gina. So great to be here with everyone today. It's been a great couple of days, and so I'm just so happy to be in person again together, and also excited to speak with these other great presenters today. So I want to talk a little bit today about technology and innovations in organic agriculture. And I know that we don't have a mic, so if people are having trouble hearing me, just put a hand up and I'll try and shout louder, especially if we have a plane above. So I'm going to start with a little bit of priming about why organic is significant. When organic agriculture did not have a public-private partnership and a formalized definition, there were varied definitions of organic and what organic meant. And so this led to a lack of consumer trust in the organic word, and stakeholders and producers came together and asked for a formalized definition of organic to protect it from weakened ideas of what it might mean. So they really wanted to protect this concept of organic. And with that, Kathleen Merrigan, who we've all heard from over the past couple of days, she was the main author of the Organic Foods Production Act, also known as OFPA. So what OFPA did was it established the National Organic Program, which created standards and regulations for organic agriculture, but it also created this 15-member advisory committee called the National Organic Standards Board. And bear with me, there are a lot of acronyms in organic. So the NOSB, we have the NOP, the NOSB, and the NOSB is really special because it allows for continuous improvement of organic. So the standards can be revisited and material review, what materials go in and out of organic agriculture. So really this legislation was baked with continuous improvement in mind. Now, the final rule to establish the NOP was officially implemented in 2002, while OFPA was authorized in 1990. And just a couple things, I know I don't have too much time, but some things about what organic means under the USDA certified organic label. Land must be managed organically 3 years prior to certification. Another thing is that once this period passes, a USDA accredited third-party certifier will come and do an in-person inspection, and those happen annually to certify you as organic. And so the standards themselves, organic agriculture prohibits use of almost all synthetic pesticides and fertilizers. It prohibits the use of genetic engineering. It requires practices to build soil quality like composting and green manures. It requires practices to conserve soil like cover cropping, mulching, conservation, tillage. It requires practices to help manage pests and diseases and increase farm biodiversity. And for organic livestock, it prohibits the use of antibiotics and growth hormones and requires access to pasture for ruminants during the grazing season. If you want a full list of all that organic means, which is a lot, it's available on the NOP's website through USDA, and I encourage anyone interested to go and read that fuller list. But why does organic matter for Arizona? Well, one of our sponsors, Patty, from Duncan Family Farms, has been around the past couple of days, and she's great. So Duncan Family Farms, it's one of the largest certified USDA organic farms, and it's right here in Arizona, which is exciting to have that in our state. Also in Arizona, we harvest almost all year with the different temperate zones in our state, and so we do pretty well with organic farming effort here. In 2019, the sales of certified organic agricultural production totaled 203 million in Arizona, which is a significant increase from 2016's 118 million. It's just over or just under 70%. Arizona is the 11th ranked state in terms of certified organic value of sales, and the number of operations was 62 in 2019. That's up from 24 in 2016. So we've seen growth and a continued and sustained growth in Arizona in organic, and that's just looking at the officially certified organic. There might be many more producers practicing organic methods that are not certified. So for nutritional security, organic agriculture is important because it focuses on sustainability. It uses less inputs. Side-by-side trials have found that organic production after a 5-year transitional period actually has higher yields during times of drought than its conventional counterparts. And in terms of pesticide and health, we know there's a lot of links between pesticides and health, like cancer and diabetes. Okay, I'm gonna skip ahead now because I want to get to the technologies. And I spent a lot of time on background, but organic is not an old way of agriculture. There's a lot of innovation in it. So we have biocontrols. Organic agriculture uses an ecological systems approach as the first line of defense, but they also allow for natural biocontrols to help manage disease and pathogens. And so there's a full list of this available on the Organic Materials Review Institute and through the National Organic Program. And so keep that in mind, as this also benefits conventional agriculture. It's not just for organic. In COVID, we saw innovations in certification. Previously, they were always in person, which can pose a barrier to some producers and processors. But in COVID, we saw virtual inspections with drone technology. And that was exciting because it reduces the barriers for people to get certified, which I love. I think anyone who wants to be certified organic should have access to that. Robots, there's a lot of exciting things happening in robotics to help increase efficiency of organic agriculture. We have weeding robots, which helps reduce manual labor needed and reduce the reliance on tillage in organic agriculture. We have robots that can help monitor what's going on in the field so that producers can stay informed about what's happening in their fields and in their herds. So it's very exciting things happening in that realm. Appeal Sciences post-packaging. Some people may have seen Appeal Sciences at the grocery store. Very cool. It's an OMRI coating. So it's natural coating that goes onto vegetables instead of plastic. And it can maintain the shelf life of these produce for 3 times longer than normal, and reduces food waste and reliance on plastic. So I love Appeal Sciences. The last thing in terms of technology I'm going to touch on is bugs, which the National Organics Program doesn't have a standard for insect protein. And that's an area I view as a growing point that I hope is going to be worked on soon with the NOSB. So bugs are a sustainable and protein efficient source of food and animal feed. And you can even have separated flowers made from crickets. And so it's delicious. I've eaten it. Gina here has eaten it in cookie form. So that's another growing area of organic. I say all this because organic production is an asset to the US farm portfolio and the Arizona farm portfolio. And it's a part of our solution for long-term nutritional security. It's a forward-thinking agriculture. With that, I'm going to drop some links in the chat and pass over the floor.
Great, thank you, Colleen. That actually made me realize I didn't introduce myself. I'm Dr. Gina Nichols. I just got my PhD recently, so that still sounds weird. But I'm an assistant research professor at the Swette Center for Sustainable Food Systems. So I work with Colleen. And who is the program manager for the Coalition for Farmland Preservation. Yeah, right in front of the computer. Sorry.
Here's a clicker for you. Okay, so going forward, back, perfect. Do I have to unmute or anything? Is it unmuted?
You're good to go.
Okay. Okay, so hi everyone. My name is Danielle Corral. I'm with the Coalition for Farmland Preservation with Local First Arizona. And has anyone here heard of the Coalition for Farmland Preservation? We got a couple. Yay! Oh, nice. Okay. So a little bit of background with the coalition itself and what we do. The coalition formed in the fall of 2020, and it formed out of a need to have a focus group on addressing the loss of farmland that we're seeing throughout the state. So we say we focus on the loss of farmland in Maricopa County just because out of a capacity, but as you all know, the loss of farmland is a statewide issue, and it's within all communities. So we really work to make sure that we have those small to medium farmers and producers. So essentially we can feed our state, right? And in most of our work is just trying to find affordable and viable farmland for our growers. And so this was actually mentioned in a session I was listening to, the Food of Our Ancestors, how they were all talking about farmland access. So it's just access to viable farmland is something that all farmers and producers deal with. So today I'm going to speak on the role of adaptive agriculture, and in the context when we're talking about new technologies and the future of Arizona sustainability, what role does adaptive agriculture play? And I really wish I could have gone right after the section that talked about the food of our ancestors, because if you're talking about adaptive agriculture, I highly recommend you listen to that recording, because that's a whole nother indigenous work that they're all doing and an approach to it that I do talk briefly about, but they've been doing adaptive agriculture since the beginning of time. So I think that's a great supplement to the kind of the approach that what I'm going to be talking about. And I'm going to talk about what is adaptive ag, what does it look like, and why is it important. So anytime I talk about a concept, I always like to define it, because when I say something is adaptive, it may not be your definition of adaptive. So adapt means to become adjusted to new conditions and challenges. And I'm going to talk about what are those new conditions and challenges for Arizona. Some of them aren't new, some of them have just become more severe. Change behavior to become better suited to the place and the environment. I think we're seeing that now, right? As things are changed, how do we become better suited, especially in the space of agriculture, having these conversations of how can we adapt? And then at its most basic level, adjust in order to survive, right? That's really where adaptations come about, is we need to survive. So I want to also just point out these pictures too. So the top picture is agrivoltaics. I'll talk about a little bit later, but that's one of the ways that we're kind of taking a holistic approach to how can we do agriculture. In the bottom right hand, I don't know if you saw that presentation by Dr. Michael Johnson. He's talking about dry farming, and that's a picture of his corn that he does for dry farming, and how the Hopi community has done this form of agriculture and adaptation for thousands of years. And then we have a picture of the lower left-hand picture is on the right, that long root structure. That is Wayuli, which I'll be talking about. It's a desert-adapted crop. On the left is a picture of wheat. And if you look at that root system, one has a really shallow root system, one has a long root system. So we're talking about drought tolerant. That long root system allows for it to assert nutrients and waters further down. So it's really important if we want to adapt to a drier, hotter environment, we talk about what are we growing. Okay, so what are the changing conditions in agriculture in Arizona? And again, some of these are just becoming more severe. At the top of the list, no surprise, is our water challenges, right? Especially in the ag community. This is something that farmers are always adapting to. So I don't know if you guys follow what's going on in the water world, but for CAP, which is Central Arizona Project, we are currently in the Tier 1 shortage, which means that they've been issued a reduction of water supply. And this is really resonates with farmers because they have the most junior water rights, so they are going to be the first that is cut from this water. And farmers, particularly in Pinal County, in a Tier 1 shortage, will be receiving as much as up to 60% of their water rights. So that's that irrigated water system that allows them to grow. So that's really major. Imagine if you were growing something and 60% of the water that you use got cut. How do we have this conversation of what we're growing? Also groundwater. So as farmers are losing some of their CAP water, they're going to look for alternatives, right? So now in the groundwater space, we already have farmers that use it. We're having larger farmers come into Arizona. So imagine you're just going to have more people at that water spout needing that water. Okay, temperature differences. I don't know how many of you were here, 3 years ago when we had triple digits for 3 months? I remember that summer because I was like, should I move? So it is becoming a hotter environment overall. So how do we talk about that when we talk about agriculture, where we're seeing higher rates of water evaporation because it's drier? How do we plant crops in a drier environment? That's just part of that. What is that changing condition and how do we adapt to it? So the third one is something I deal with daily when we're talking about farmland loss and land access, urban sprawl and rapid development growth. So the figures here I have from MAG, that's Maricopa Association of Governments. This is specific to Maricopa County. It's showing you the rates at which some of our cities are growing. So you have Queen Creek 9%, Buckeye 8.9, Goodyear 5, Surprise 3.8. So what does that mean? Those are high rates of growth. In other ones, you might see anywhere from 0.5 to maybe 3. Where is all that growth coming from? It's taking up these lands that used to be agriculture and now building developments, building facilities, industry. And why we realize, it's natural, not say it's natural, but we're in a context where we're getting more people who want to come live here and we understand development needs to happen. We need to have a space where we talk about how are we developing and how are we going to feed all these people. If you lose all that farmland, how are we going to feed them? And also the environmental benefits of agriculture land. If we now just start to build more of these concrete buildings, how does that affect the urban heat island effect, right? Because now that it's so hot here. Also, not to mention all these food coming in here, people coming here, our food supply. We're going to have higher and higher demands of food. So how are we going to feed people? And then finally, we can't work in a bubble. Anything that happens to state and U.S. and global affairs, it all affects the food system because we are a global food system, whether we like it or not. I think there's definitely communities maybe that really focus on more subsistence, which is great. And we try and emphasize having a local strong food system, but we are a global food system. So even right now, what's happening with, in Ukraine and Russia, that's affecting wheat supplies, that's affecting gasoline supplies, all of that. So how do we adapt to the changing condition? So what is adaptive agriculture? The reason I don't have like a list here per se is because it is really based on your environment. So I have principles here, right? And I think the number one would be it's highly contextual. Adaptation at its core is a locally adapted solution to what is going on in your environment. So that's why I say a great presentation to listen to is the role of our ancestors, because they talk about how they use that localized approach. It's very place-based. You know your land, you know your soil, you know what you need, you know what you need to adapt to. It's also very systems oriented. Sometimes in agriculture, we try and have some people have a linear approach to things, right? We'll just grow this kind of crop. We'll just bring in inputs, and they're not looking at the ecological system and how one thing affects the other. You grow something here, what other plants do for here, what is the water? So adaptation is really that circular holistic approach. Adaptation is continually responsive. It's funny, Colleen talked about how the organic and all of that is continuously, improving. Same with adaptation, right? It's continually responsive, and it's so important to have that approach, especially if it's locally adapted solutions. Yeah.
Get the slides here.
Not working.
They're not sharing on the.
And the last one, I'll just keep going while she's doing that. So it's very process driven and outcome oriented. And I really stress the process driven part. We have to ask ourselves, what are the means? How are we going about when we pose these solutions? And then outcome oriented, like what is adaptation all about? It's like, are we trying to build a more resilient food system? How do we adapt in order to do that? So what does adaptive agriculture look like? And again, I'd go back to the food of our ancestors. They have beautiful examples of how they're doing adaptive agriculture. And they show just the beautiful work that's being done with seeds and how a seed has been, through thousands of years, how it's been adapted to its own environment, whether it be water, sunlight. So I would definitely take a look at that presentation. What does it look like? I've kind of touched upon this, but it basically means being open to questioning what we grow and how we grow. And that's the space I work in right now, is we need to have these conversations with maybe we've been growing things that are very water intensive. How do we adapt to that? Because is that even possible anymore? It includes integrated technology, and I always stress, but it cannot replace biology. Sometimes there'll be an approach of technology is a solution, and we say technology is part of the solution. So technology has a role, but knowing the ecological process are very important. Dr. Michael Johnson brought this up, as well as Dr. Melissa Nelson. It's Indigenous ecological / agricultural knowledge. So Dr. Johnson brought up that it's now been officially recognized as science, but I think there's been a space for thousands of years that has known this as a science. And it's really great to see them being moved into this space when we're talking about agriculture, because there's so much knowledge there that can be shared as we're coming up with these local adapted solutions. Combining modern science with ancient practices. So I really love this approach, right? What new things are we researching and coming up with, and how can we marry it with these concepts? Regenerative agriculture is all the topic now, but it's based on a lot of ancient practices. So how do we marry the two, make sure people are getting the credit they have for what they bring to the space? And then diversifying crops and using traditional methods to work with the environment. I can't stress that enough. I think we've had an agricultural system that has been saying, what we want to do, how much we want to grow. We want to grow just certain kind of crops. We want to just have certain inputs and manipulate the factors in order to grow such high yields. Well, I think we need to step back and take a look at that, even how we're thinking about, is it just about profits and productivity, or is it about how we're doing it? Okay, so some more pictures. It's really hard to talk about adaptive ag in like 15 minutes. So Good Food Finder has a great page called Adaptive Agriculture. I will put some of that, I don't know if it's in the chat box already, but I can put that in the chat box. And we also have an Indigenous Pathways, Voices from the Field, where we give other examples like a food forest. That's adaptive agriculture. There's so many small movements and organizations and solutions going on right now that I really encourage you just kind of go down that rabbit hole and look at like, how are people adapting? And then on the left, I have pictures of one example when we're talking about like, okay, let's talk about what crops we're growing. So wayuli is a crop that is native to Mexico in the Southwest, and we're now using it to grow it as a rubber substitute, or a latex gloves, right? So usually we import rubber from Asia, and Bridgestone is now investing, Bridgestone fires, like you ever get fires from Bridgestone, they're investing in growing this crop and seeing how they can use it in tires. And then other ones are getting in this space and seeing how we can use it for like gloves. It's a very drought resistant crop. It grows really well in arid environments. It has that long root structure I showed you. So again, it's just using an approach of, okay, rethinking what are we growing and how are we growing? And then at the bottom, I have agrivoltaics. We have a couple farmers that are getting in this space right now. So we have a small farmer, Maya's farm, that she's going to be beginning that. We have a farmer in Douglas who's been working with the U of A Cooperative Extension and Biosphere, they've been doing research out there on their own farm, and he wants to incorporate that. In Colorado, we actually see working farms who are doing agrivoltaics, and I should explain what that is, right? So it's where you have solar panels on your farm and you're growing crops under it. So you're producing energy for the farm, or maybe they can link into the grid system and produce energy for the community. And then these crops are shading the agrivoltaics, the panels. So I don't know if you know, but with solar panels, for them to actually work at top efficiency and so they're not replaced, right? Like just you use them out too quickly, they need to be cooled. And a lot of times you see solar panels just out on top of parking lots, you see them on open fields, and they're not actually producing the maximum amount of energy they can have. So talk about if we really want to, use something to its full potential, keep it at its maximum operating temperature. And that's what these crops can do. And then the crops themselves, instead of them evaporating a lot of that water as the heat is beating down on them, you have the solar panels that cool them. So it's at this beautiful holistic approach of food, energy, water nexus, right? That's why I love this as a technology approach, because it has a holistic approach to it. And it's thinking about the whole circular system. So why is adaptive agriculture important? I think I've talked about this already, but let's bring it back to like my work that I do. So with the coalition, a lot of our work, we're in a space where we're trying to make the case for farmland. As we're all growing, why do we need to save our farms? At a basic level, you think, well, we need to feed people would be really an easy, point of view or argument, but it's not always, right? Because food shows up at the grocery store. We're in a place where we have Mexico, we have California, so we import a lot. So we're trying to show that, showing by how adaptive agriculture is, how important it is part of the solution to the climate challenges. We're talking about how to sequester carbon and to save water. Agriculture is prime in that space, and adaptive agriculture shows you how these growers have been doing it for so long. Agriculture is very relevant and responsive to the times. So right now, as we're talking about water, it's brought up that 70% of our water is being used by agriculture. I mean, I can also counter that with like, well, it's not just water going down the faucet, it's water coming out in the form of food. So it's not really a one-to-one conversation, but let's just talk about how it's using 70%. Okay, so let's talk about what we're growing. Instead of just getting rid of it and saying, oh, we got rid of it, that kind of solves our problem. Let's talk about what we're growing and how we're growing and how we can work within that 70%. I love agriculture because it just meets at the intersection of what we're talking about, food, energy, and water. We're like, you really can't talk about that, miss one of those components when you're talking about agriculture. And then finding solutions to feeding communities with limited space and resources, adaptive agriculture and all these like local communities are great at that. As more and more people are here, we're having less water, less room. How do we grow and feed our communities? And finally, it shows the need to invest in new markets, ag approaches, and ways of thinking. Adaptation is just about that, right? We have to be open to changing. And so I want to leave you with a question of showing you what adaptive agriculture can do, and this is just a small representation. How well are we investing in adaptation versus supporting the status quo? With that, I want to say, like, are we actually investing in our small growers and the people on the ground who are doing adaptation every day via policies, U.S. Farm Bill, subsidies, crop insurance, grant writing? Are we supporting the people who are really having these solutions, viable solutions, and incorporating technology? Or are we still supporting the status quo and monocultural industrial approaches, crops maybe that still cannot be grown in an environment that is changing with water and temperature? So I don't know if you want to answer that on your own or the question and answer, but I always just kind of like to leave a final thought. And we're going to do questions at the very end.
Thank you.
Yeah.
All right. We have another presentation, I believe. Yeah. All right. Dr. Edward Martin. Wait while we pull that up. And he is the interim director of the University of Arizona Cooperative Extension.
No problem.
Took it back. Thank you so much. So I'm just going to say ditto from everything that Danielle said. So that's the future of agriculture. She's got it covered. So thank you very much. Appreciate it. Now I'm going to talk to you a little bit more about production agriculture. We're going to look at that a little bit closer. But before I do, I want to talk to you just a real quick second. I'm going to change so that people can see me. I'm a little taller. Cooperative Extension, what is it? Cooperative Extension is the outreach arm of the University of Arizona. We have offices in all 15 counties. We have offices on 5 tribal nations. They're called FERTAP offices, federally recognized extension tribal programs. There are 35 of them across the nation. These agents, 7 of them are in Arizona. We have them on the Navajo, we have them in Hopi, on the Crit, Wallapai, and San Carlos. We also deal very closely with many of the other tribal nations. Yes?
Take a quick look at this.
All right, take a quick look. So anyway, I'm going to continue talking. So those of you that are out there in the state, contact your local cooperative extension office. You've got a question about agriculture, you got a question about food, talk to those folks out there. They're available to you. This is a little map we're working on right now. We have well over 2,000 collaborators, partners that we work with throughout the state. So we're not just in Maricopa County, we're not just in Tucson, we're all over. So I just wanted to let you know about that. Now this is not working. I can just click the button.
Let me see.
Oh, now it's working. So this was quite a task. Talk about the future of agriculture. Someone last night asked me, so what are you going to say? And I said, I don't know. I'm still working on the presentation. And after what I heard today, I'd probably change it even more. I've been here since 1992 in Arizona, and I've seen quite a change. And it's been nothing short of amazing for me. Let's talk about water, right? Reservoir levels. When I came in 92, you did not see this up in Lake Mead. Colorado River, that's also getting down there. And we've already talked about tier 1, right? And those of you, it's already been explained. We've got growers that don't have enough water. So what are we doing? Well, we're not going to be doing what we used to do. We're not going to be irrigating the way we used to irrigate. We've got to be looking at different ways. We might be able to use some high efficiency center pivots and sprinkler systems. These come a long way since I worked with them back in Michigan back in the 1980s. They've got drag hoses now. They've got individual flow meters on them, so pressure regulators. So they can come close to 90% efficiency. That means 90% of the water they apply actually goes into the plants, and only 10% is lost. We have drip systems now, buried drip systems. We've had these for years. You can see here that's the manifold that's sitting up above ground, and you can see the tape that's buried. This is what it looks like when it starts irrigating, right? Now we're not irrigating the whole field. We're irrigating a single line. We're irrigating right where the plants are. These systems approach close to 95% efficiency. We only lose about 5% of the water to evaporation. And so it's very, very efficient. If you want chemicals or fertilizers applied, very, very precise. These can be also used in organics, just to let you know. This is not an inorganic, not organic. This is an irrigation system. If you want to put fish emulsion through this, that's fine. You can put your organic chemicals through this just as well. And some of the systems also work on top of the ground. So it doesn't have to be big, doesn't have to be gigantic. Some of the designs vary. And so there's a lot of things that are happening right now in the irrigation that will allow us to take advantage of higher efficiency systems. However, these things do not come without their challenges, right? Pocket gophers. They don't chew to find water, folks. They chew to chew. They just do that. And so you have this drip irrigation system that you just invested, and you put it out there and you find out you have a whole bunch of pocket gophers living in your field, and you start seeing these little sprays put up. So there is a little bit of a challenge. And even with the center pivots, right? The wheels, You're going over things. You got to cross over things. I've actually seen a center pivot up on the side of a barn that I guess the automatic stop didn't work and it started going up the barn. I've heard about them running over cattle that were out grazing. So it's not without its challenge. And these systems require a little bit better water, right? Higher quality water than we're used to with our surface systems. Both drip and sprinkler. Drip probably a little bit more. And the other thing, let's be real, these systems cost money. It's not easy. And many of our growers in the state, the big growers that you know of, and you see the large systems, they don't always own their land. Quite often that land is being rented, and for them to spend money to actually put in a system is quite high. But you know what? We can't do it just through irrigation. We're going to need to be using some other techniques. And technology is something that growers need to embrace, and they actually have been right along. Things like automatic lettuce thinner, right? We don't have the population anymore. I know we talked about getting back to the land and how we need more people involved in agriculture. Well, the truth of the matter is we don't have that right now. And so we're looking for alternatives. This is an automatic lettuce thinner. They're also looking at injecting steam into the ground. This is something I just saw in Yuma a couple of weeks ago. Kills the weeds, kills the pathogens. We don't have to spray any chemicals. Sounds great. It also looks like it's also moving salts out of the root zone. So that might be something that we'd be looking at. Field Scandalizer. This is something new. This is not GMO. What they do is they plant a whole bunch of plants, and this is at the Maricopa Ag Center at the University of Arizona, just down in the city of Maricopa. It looks at individual plants, and it looks to see if that plant is growing very well in our environment. And if it is, it will identify that plant. Now we're going to harvest that plant and harvest those seeds and try and grow that out and see if we can get the genetics that way rather than trying to inject them into a plant or anything. So this is a field scandalizer. It gets all kinds of information. This is the data age, right? Information is what's key here. We also look at genetics. Once again, we're not changing the genetics of cattle. We're just using the genetics, using the information that we're getting from them, and trying to make sure that we're using good crossbreeding to improve herd quality. And once again, that can be organic too. So drones are becoming really big, not only in size, but in use, right? We use drones now to assess plant health. So you send a drone out there so it can look at the entire field, right? And it can tell you what the status is and the health of your crop is. We can also use them. They're big enough you could spray. So if you wanted to spray some BT on your cotton or some BT on your crop, if it's an organic crop, it would know exactly where it is in that field, where the problem is with the bugs, and it could put the spray on. Or if you wanted to spray on a fertilizer, you could take a look at that and use that. This one's hard for you to see, very hard. It's got a little circle there. We're also using drones in palm trees and for dates, right? And they actually use the drones to fertilize the dates. And so they spread pollen among the plants. This way we get a more efficient system. So all of this comes down to using data, right? This is a field map of yields. It identifies the areas where you have good yield, where you have poor yield. You could go out, find out why you have poor yield. Maybe you'd identify a corner that has poor soil. And you know what? We're not going to plant that corner anymore. It's not worth planting. We're going to just leave that one fallow because basically we don't get the yield out of it that we need to. And we start identifying zones. And if you have a center pivot or if you have a drip, now you know where that zone is. So now I'm going to put a little extra fertilizer there, a little less over there. And you're going to have prescriptive irrigation and prescriptive farming. And then, of course, GPS it's almost everywhere now, folks, on tractors and all for production agriculture. It's huge. I remember back in 1992 when I got out here, and if you had a straight row, you were real happy. You had a good tractor driver. Everyone was cheering. But I mean, there have been times when those rows, now they know exactly where they are. And not only do I know where I am, I know exactly where my plants are. So when I go through to cultivate, I know exactly where the row is. So I don't have to worry about hitting those plants, and it's much more efficient. And then also, you're going to have to start embracing new crops and new cropping systems, right? We're going to start growing stuff differently. growing in controlled environments. That's going to be something that we're going to be looking forward. And growing things in different geometries, right? Vertical farming, whoever thought, you know, what are we doing here? Let's start growing some stuff here. So this is something that we're going to have to take into account and the future will hold. And this is good old Waiuli. Yes, I brought it up too. I know much of it. U of A is working very closely with Bridgestone down there. Bridgestone's talking about putting in another 20,000 acres of Waiuli in Pinal County because it uses less water. When we first started looking at it, we thought, well, the more water you get, you apply, the more plants you get, the more growth you get. Well, that was true, but they were finding that the quality of the rubber was not as high. And actually, it didn't work that way. So now they've gotten to a point where it actually uses less water in order for you to get an economic crop out of it. So, in conclusion, where's the future of Arizona agriculture? Well, part of it is with the kids, right? The FFA, the 4-H kids, right? I mean, that's our tradition. And I think that's fine, and we still work very close with them. But it's also in the education, the Summer Ag Institute that the University of Arizona has, Ag in the Classroom. Folks, you know, there's 4.7 million people in Maricopa County. It's pretty much urban. We're an urban state. We have a large rural area, but we're an urban state. We need to make sure that those folks have a connection with agriculture. And so what we do is we bring the kids out, right? We start talking to them about where agriculture, where things are grown, how things are grown. Let them talk to a few growers and some producers. Let them see a farm and see how the animals are being taken care of. These people are, you know, the growers that I know and the producers I work with, they have a great appreciation for the animals that they work with. They have a great appreciation for the land and for the soil that they work with. I even like this is a picture, it's an older picture. We had actually teachers come out to the Maricopa Ag Center and see if they could do some siphon tubes. And I'll tell you, it was a bit hard to do that. These are the tubes they use in irrigation. So get folks out, let them learn about agriculture. So where is it going to be? It's going to be where the water is. It's going to be in Yuma, where they have high rights on the Colorado River. It's going to be in Native American lands where they have the water. It's going to be where the folks are growing crops that are high value crops. It's going to be where folks are taking advantage of genetics to improve their herd. It's going to be in different places. It's going to be under hoop houses. It's going to be in buildings. It's going to be in greenhouses. It's going to be crops like dates that are very unique and have a very strong market. It's going to be where the folks are using the technology in order to maximize the efficiency of their production. It's going to be where people are paying attention to folks like you. They're going to start paying attention to being certified public or products from sustainable agriculture and farming, grown locally. It's going to be folks that are listening to their customers. I have growers that are growing organic corn, sweet corn. Asked him why he grew organic sweet corn. It's a grower out in Mesa. He said, because that's what my customers want. That's why he's growing it. Cage-free eggs is because that's what customers want. So you all have the ability to help form the future of agriculture. And growers that learn to adapt to a change. Adaptive agriculture. It's a nice one. I'm coming after her. I felt like I don't even know why I need to talk, but that's all right. So the truth of the matter is that the future of agriculture is going to be the growers that adapt, that innovate, that understand that they are working in a global market, but also that look at the local markets to make sure that those are being taken care of as well. So I think that's all I have. And I thank you very much for your attention. So thank you.
Great, so we're gonna have the speakers come up and we'll switch off between questions from here and the Zoom folks. So right now we can start. Does anyone in the room have a question? Or any of the speakers?
Sources.
Yeah, no questions. Oh, yeah.
So for the University of Arizona.
Sorry, we have to repeat
Oh,
the
yeah.
question.
Oh,
Thank you.
Oh, carbon sequestration in the soil, is that something being talked about?
So yeah, we're working on that at the University of Arizona. And so we're looking at doing a long-term study at the Maricopa Ag Center just in that. We just hired a soil specialist and he's very, very much interested. It's something that's been happening quite a bit around the country. We haven't done a whole lot of it here in Arizona, but we're thinking that we need to start looking into that because yes, that's definitely an area where we might be able to make a difference and make start sequestering the carbon, and that's the more sustainable, right? We're getting back to sustainability, so sustainable farming. So yeah, it is something we are looking at.
And I will say that the USDA has a climate smart grant out right now. So I know that Danielle and I are working on an application. We actually would love to bring the U of A into that. We've really been looking to bring whoever we can and have a wide partnership. We're not very far along in the process, but yeah, anyone who's interested in working on carbon sequestration, we're hoping to bring a band of Arizona stakeholders together and try and study some carbon sequestration more with that USDA grant opportunity.
And then if I can add to it, so there's actually some great work going on now. So there's one called the 1,000 Farms Initiative. So this is one that is started, it's going to be throughout the US. They're doing 1,000 working farms. So something to distinguish when we're doing research. A lot of times research will be done on research farms. So they'll be researching like how much carbon is being sequestered. And while that has its own place, sometimes when you then take that research and you put it on a working farm, the context doesn't work. So what's really important about this 1,000 Farm Initiative is it's going on working farms, farms that have already maybe been doing regenerative, organic, native, there's so many words, but are doing their own practices, and they're going to measure what carbon sequestration has been used. A lot of times it's on grasslands because in order to sequester carbon, you do need to have a lot of foliage, vegetation. That's how you bring the carbon down. But it is on also vegetable farms and such. But so it's taking these working farms, collecting the data and showing how much carbon sequestration they have already been sequestering, or as they're transitioning and going from conventional to this regenerative approach, what's the change in carbon sequestration? So that's one great project we're doing. There's another one, and it's escaping my mind, but I know there's two big movements going on in trying to measure that. And another project that talks about carbon sequestration, I had it on a slide, I didn't mention it. It was a picture of, it was called the 1,000 Agave Farm Project Initiative. So this is actually in Mexico, but we're hoping it's going to make its way to Arizona because what they're doing, they're in arid environments, which would be very similar to Arizona. It's a high desert arid environment where this is happening in Mexico. They're taking agave plants, growing them alongside mesquites, and then rotational grazing with livestock. And this is so amazing. So agaves, when you ferment them, they can actually be animal feed. They can be fodder. So when you're talking about how do we feed animals, if we know, growing alfalfa is water intensive, what are some other alternatives? When you ferment livestock, you can feed the animal. You're doing a regenerative grazing. So that's carbon sequestration via what you're growing and also the livestock. And then you're incorporating mesquite into it. So you can actually get mesquite pods, that makes mesquite flour. And it's very nitrogen fixing mesquite trees. So it's this holistic, beautiful system, and they are sequestering carbon and they're measuring that. So there's so many amazing projects going on in this carbon sequestration, which has been happening, but maybe it hasn't been measured. And then also the work that they're doing at U of A too. But I really love this concept of doing it on working farms because then we know it works because it's in its own context already.
So the question is, how do small farms get technology? And one thing that I would say is really important is open source technology. And so open source technology helps with equitable distribution because anyone can access this technology. So that's one point that I have. I think we really need to focus on open source technology for equity. So for organic certification specifically, there needs to be a few different things that need to happen there, but cost share. So there is a cost share program for certification for organic agriculture. And it at one point was up to 75% of the cost of certification could be reimbursed, but then funding would run out, or now it's 50%. And so that's something on this farm bill that I'm really interested in seeing. And a lot of people are pushing for that in the upcoming farm bill, is to restore organic cost share program back to what it was, and even I'm hoping increase it to 100%. Another thing is technical expertise and support. So there's 9 out of the 17 USDA agencies that work in organic, and even with that, there's an unequal distribution in terms of knowledge about organic. So someone might go to their FSA agent and they might say, organic, what? So if you don't already know these inner lingo and practices, then you're not getting that technical support that you need. And so we need to really see a cross-agency push. We need to increase funding and technical support for those who want to learn about organic. We also need language equity. So we need to have these resources in many languages. I was happy when Spanish was added to the National Organic Program, but that's not enough, right? We need to expand the languages that we see these resources and materials in. I could keep going on and on, so I'm going to pass over, but yeah, there's a lot of work to be done. And so hopefully we will see that happen.
Okay, so a great question, kind of did it to her. So, and talk about, let's talk about agrivoltaics, that's technology, right? So we actually have farmers who are trying to find access to that. So it's like the grant process, which is why when I ask, are we investing in adaptation with these small producers? Because it can be very hard to find funding for them. Sometimes as a small grower, it's harder to do proof of concept. It's harder to have some of the documentation they want, even just the language itself to apply, but it is there. There is grant money coming out. There's a new one, which USDA is promoting. I don't know if you saw Secretary Vilsack speak about it. It's the Climate Smart Commodity Grant. So that's supposed to help with this climate smart commodities. But it can be difficult too, right? Because if you don't, it can be hard to apply for these grants because when you're working with small producers and you're talking about commodities to maybe have an established commodity yet. So it's there, but I think it's a great question because, yeah, how can you talk about technology if people don't have access to this technology? So that's when we need to ask ourselves, are we investing? Are we making it easy? Are we doing incentives for these small growers to have access to that technology? So I love the concept of open technology. We're seeing that a lot with apps. So if they can get, like, I didn't mention drone, which I'm glad you did, because I'm seeing even in like a small rural environment, you have people who are doing drones, right? And then it can tie into a free app they use, or they pay minimal and they're using it to monitor their crops, or they're using apps to communicate to their consumers. So that's kind of a space that we see that is accessible with the cell phone. But if you talk about some of these larger technology pieces, I think that's a great question of like, yeah, how do we get them access to it? So I don't know if you want to go on that.
Yeah, if I can, just real quick. So we're working very closely with the USDA NRCS. And so they're looking very closely at trying to do programs in the urban sector and small and beginner farmers. Taylor, raise your hand. Taylor's actually our person at the Maricopa County Cooperative Extension Office. So we have that program going. I just had a meeting with them, and they're looking to change the language so that FSA and some of those other government agencies that are used to, helping growers that have, hundreds and thousands of acres, we're going to start looking at helping growers that have, tens and 20s of acres, and that's something smaller. And so we're working on that. We have a program. So the technology is coming. The other thing that people have done is form co-ops, right? And so usually as a co-op, then you can purchase and then you can share the technologies between you. So, Monday you get the drone, on Tuesday she gets the drone or something like that. So anyway, check with Cooperative Extension, check with Taylor.
Perfect. Thank you. It's time. So I want to thank our speakers. Yeah, and thank you, the audience. So, and Zoom.